So yeah, I'm Yogi. I'm not Kannan. I'm from Yugabyte. I'm a principal solutions engineer based here in Singapore, and I've been living here for close to 20 years. And I'm seeing a lot of regular folks. And thank you very much, Rakuten, for actually hosting this event, and of course, TechTune and Data Engineering SG for hosting us. Today, we are actually going to hear from Kannan, who's our co-founder of Yugabyte DB. I don't think I have actually ever heard from another co-founder or founder in any of our Singapore meetups. Probably this is the first one for me. Hope it's first one for all of you all. So without any further ado, Kannan, over to you. Oh yeah, I'm sorry. Sorry about that. We are here. Obviously, the event is organized by IMDA. The wonderful dinner was organized by them, and we'll be hearing from IMDA team a lot more about some of the key activities that they are doing. And I'm sure you will find something really, really useful for yourself and for your like if you're a startup yourself. They have quite a few programs that can actually help you in accelerating it. So they would be sort of presenting after Kannan. So without further ado, Kannan, over to you.
Thank you, Yogi. Hi, everyone. First off, let me also start off by thanking three groups of folks. Rakuten for providing this beautiful space for us to hang out together. The IMDA group for helping organize this and bring us all together, hosting this wonderful event, and the data engineering group as well for helping bring this together. So it's my pleasure to meet you all in person and walk you through a little bit of the database journey, right? We titled this track Evolution of Transactional Databases. It's a little bit like if I ask my son or daughter about cassette tapes versus what they are, they're going to probably be puzzled, right? Like when they're so used to streaming media, a lot of us went through cassette tapes, VHS tapes, mini DV camcorders, you name it, CDs, DVDs, Blu-ray, all of them. And so please bear with me as I hopefully walk you through a little bit of similar journey on the database side of things. So I'm going to take you back a little bit in time. So it's a trip down memory lane. And we're going to go back to 1960s. And we aren't going to spend too much time there, but I think sometimes it helps to get a feel for where we came from, right? And 1960s, if you think about like databases, mostly they were called like information management systems. IBM was kind of the thought leader here. And much of what we had back then were essentially hierarchical databases. I mean, data was laid out in a tree-like structure, 1 to n relationships. And this all looks good, but main issue was the way you accessed or queried your data was too tightly coupled to how data was actually laid out on disk, right? And the more tightly coupled it is, the less flexible it becomes to change things after the fact. Fast forward a little bit, but still in 1960s, that hierarchical data model was enhanced to be more graph-like. So suddenly, instead of just 1 to n relationships, you could model m to n relationships. A project could have multiple departments. A department could be part of multiple projects. So a little better than the first version, but still fundamentally, the way your applications accessed your data was too tightly coupled to how the data was physically stored on disk, right? And that's where a seminal paper in this whole space came out, also from IBM, but this is the research side of IBM. So Cord in 1970 published this paper called A Relational Model of Data for Large Shared Data Banks. So notice that even the word databases hadn't quite become popular. Databases were called data banks, right? And his whole observation was to break the problem statement from the previous database, which is underlined, that wouldn't it be nice to decouple query access from the structure of the data, right? So at the end of the day, a database or a data bank is nothing but in his view of the world, it's nothing but a collection of relations. Each relation is like a table and a set of tuples. And the relationships between them are more like pointers, right? But they're implicit, and he also said, hey, there needs to be a query language that is decoupled from how data is laid out. But his was more like a mathematical sort of paper. He didn't actually propose a more human readable version of the query language. So let's fast forward a little bit. And remember, that's sort of the research side of IBM, right? But the commercial side of IBM at that time, they were mostly working with their IMS, their mainframe system. So they were busy. They didn't quite, pick up on the relational proposition that Cord was suggesting. So at this point, I'd like to take a quick pause and maybe ask you folks a question. Which one do you think is the first relational database? In, DB2, okay, close enough. Oracle, good guess, but not quite. Not quite. Not Yugabyte. I wish. So let me give you a clue. This came out of Berkeley. Okay. 5, 4, 3. Sorry. That was still later. I'll give you the clue. So this person is the creator of that database. Anybody recognize this face? His name is Michael Stonebreaker, a professor at Berkeley. And the database was called Ingress. And as you can probably guess, Ingress was the precursor to Postgres, but it had its roots in Berkeley. It was Ingress stands for Interactive Graphics and Retrieval System, right? And I mean, it's essentially Cord's idea, the paper that he had published, but now starting to be put in a practical implementation of building a system. And you start to look at the query language. It's SQL-like. It's not quite SQL. It's slightly different. It's saying give a 10% raise to Jones if that person works on the first floor, right? It's like some little join between the employee table and department table. SQL-like syntax, not quite there yet. Let's fast forward. I should probably use the clicker. Okay. So at this point, IBM picks up work on their system R. And they published this paper, Relational Approach to Database Management. So this is taking Cord's idea further and actually introducing SQL. But notice that it's spelled SEQUEL. It stood for Structured English Query Language. But pretty much your familiar SQL syntax starts to show up here. But in that paper, the underlined last sentence is worth reading. We emphasize that System R is a vehicle for research in database architecture and is not planned as a product. So at this point, it's still a very research effort coming on from IBM. And the main commercial arm is busy selling the IMS systems, mainframe-based, right? Okay, so around this time, we're now at 1977. Anybody recognize this team? The one person you're likely to recognize is the person on the right, far right. Pardon? 100%. We have some student track to get. So that's Larry Ellison, still kind of the co-founder, chairman, still active at Oracle. So that's essentially Ed Oates, Bruce Scott, Bob Miner, and Larry Ellison. And these people are the co-founders of Oracle. And they are actually, you could say, while Ingress was the first relational database, but it took time to market and becoming a commercial database, it was really Oracle, right? And Oracle raised, so 1970, the Cord's paper was published, and 79, the first commercial SQL-based RDBMS was launched. And In fact, initially Oracle went after more analytic use cases, and later they started adding multi-version concurrency control and row-level locking, PL/SQL stored procedures. 1992, I mentioned because that's when I was in grad school. I took my database course from Michael Stonebreaker, who had already moved on from working on Ingress to Postgres. Stonebreaker hated Oracle. It's like friendly competition. It's like, he's working on Ingress and Postgres, and Oracle is making moves. 92, I was a grad student there. I actually ended up joining Oracle after graduating, and I spent about 13 years of my working life. My first job out of college was at Oracle. Fun times, great learnings, working on and building a relational database. Let's keep going. So there's a little bit of happenings in 1980s. 1979, I remember Oracle launched, and then eventually IBM did launch a relational database, DB2, around 1983. 1987 was Sybase. 1989, Berkeley did a take two, right? It's a lot of learnings from Ingress, what competition is doing, and they launched Postgres. So Postgres is still a very active database. People may think it's a much younger database, but it has its root almost like, a long time back, 35 years or so, right? Microsoft SQL Server, did people know that Microsoft SQL Server was largely based on Sybase? Anybody here? Sybase, I think 4.0 or something, Microsoft licensed that code, took that as a starting point because time to market was important. So they said they started with Sybase code as a starting point, but after that, the journey's forked. Microsoft has continued to extend the SQL Server. MySQL was actually a little later, 1995, and then during the dot-com boom, MySQL had a phenomenal rise. But any questions though before we go on? Yeah, so while a lot of activity was happening in the database space, I think by any measure, I think it's fair to say that Oracle sort of, reached a kind of leading spot in that ecosystem, right? And it's worth reflecting, some of the key reasons that behind Oracle's success. And today we talk about this a lot: compatibility, portability, connectability, right? So Oracle paid a lot of attention to those. Like as an example, DB2 primarily ran only on IBM mainframes, right? But Oracle from the get-go was very careful about making sure that it ran well as a database in any hardware, RISC architecture, CISC architecture, Solaris, HPUX, and later Linux, early on like Windows and so on, right? So those kind of decisions were key. But remember, what compatibility was another angle. They said instead of introducing a new dialect of SQL, they're actually going to support IBM's SQL, the SQL language that IBM popularized. So they played a very thoughtful game in terms of keeping the API something people were already familiar with, not inventing new APIs, but focusing on things like portability and interoperability with other systems. Okay, so that was a little bit of the early era of transactional databases. So let's fast forward into the demands of the modern enterprise and the pressures it starts to put on databases. So when things were simple, for a lot of us, a database was sort of the same thing as a relational database. We didn't really think too much. When people said a database, they thought ACID, consistent, transactional. They thought of relational databases, but that isn't the case as much anymore. Also, back then, downtime was somewhat accepted as a part of life. If you had to upgrade Oracle from version 7 to 8, you had to take some downtime. If there was a node out, your recovery point objective, recovery time objective, there's some flexibility, right? But for most purposes, a single database node was mostly sufficient. If that was not sufficient, run your database and take a small downtime, and run it on a larger instance, export, import. So that's mostly how business happened. But the demands of the newer applications meant that the innovation couldn't stop, right? And so the market was starting to pull the database industry in a few different directions. What were companies like Oracle doing, right? So Oracle introduced Oracle RAC. Mostly people here familiar with Oracle RAC? And RAC stands for Oracle's acronym for RAC says Real Application Clusters. But in some sense, it was Oracle architecture taken from single instance database to a distributed database, but distributed to a limited extent. What do I mean by that? It still needed like a custom infrastructure to run on. Oracle RAC can scale up to like 4 nodes, 8 nodes, and so on, but it needs InfiniBand and things. It's not like running. It's not something that runs on commodity hardware, commodity infrastructure. Right? So that is one dimension where companies like Oracle were trying to make their databases more highly available and distributed and scalable. And of course, the other trend that happened is the movement towards NoSQL databases, right? And I there are two arrows here because actually there were two paths towards NoSQL databases, and some people were going towards NoSQL databases more to deal with unstructured data. And that path to NoSQL was more because there was a certain appeal to just doing less structured storage and have a lot of flexibility and being able to put anything in a database and just store it, right? And that was a huge wave around popularity of systems like MongoDB. But there was another reason for NoSQL, and that is more when there was a need for scale, elasticity, built-in resilience. So like applications that simply were outgrowing what a single instance database could do. If you needed the scale, elasticity, resilience, and ability to run on commodity hardware, there was a huge surge of activity from Google. Bigtable happened. Dynamo was the paper from Amazon. And there's Amazon still offers DynamoDB as a cloud database service. Cassandra was work. Cassandra and HBase was work. Me and some of my colleagues we did when we were at Facebook. So after my stint at Oracle, I went over to Facebook. I'll cover some of that a little later. But yeah, so suddenly going from a world where database meant relational database, there are so many paths here. This bucket especially was kind of giving up on asset guarantees, consistency, semantics, transactions. So there's a whole growth of like dealing with eventually consistent databases, but it presents some challenges. Eventually consistent databases are good for some use cases, but not enough for many use cases, and we'll talk about some of that. Cool. Any questions? Always happy to take and interrupt. All right, let's keep going. Let's look at what some of the internet scale or companies like Google and Facebook were in, and for like around 2010s. So that I'm one of the co-founders at Yugabyte. My two other co-founders are people I met at Facebook, and Amit here in the audience. He's another engineer that we all work together at Facebook. He's now settled in Singapore, but he was an early member of the Yugabyte team as well. Around the time when we joined Facebook, maybe this was around 2007 or so, Facebook was mostly running on a manually sharded MySQL infrastructure. So lots and lots of MySQL instances, and Facebook's user base was growing rapidly. So they were constantly adding new servers, creating more MySQL instances, and rebalancing all the data. What started as like a four server MySQL setup over time grew into thousands and thousands. And Facebook had built a lot of operational expertise around managing the sharding across MySQL instances, right? But you can imagine that's a lot of heavy investment in the operations and maintaining it. And they were always afraid of launching new features because that would put pressure on the database layer. And what do you do? So they started adding caching tier. So people use Redis or Memcached as a cache, and Facebook often use Memcached as a caching tier. And this architecture is complex enough in a single data center environment. But what if the data center goes down? So you need a DR story, a disaster recovery story. So the complexity of using a traditional database like MySQL was massive, but Facebook had large operations and SRE teams that were building infrastructure to run and manage that. There was the MySQL level replication happening between data centers. The caching tier was doing its own replication between data centers, and all of this had to be kept consistent. So sometimes the application responsibility to keep data between the caching layer and the database consistent. But you can imagine that in a multi-region architecture, it's a lot of complex infrastructure. And when data becomes inconsistent, you need to write a lot of manual recovery jobs to bring consistency back. That's when we started investing in simplifying that operational database infrastructure and working on distributed databases like Cassandra and HBase. And Facebook Messenger was one very large use case we put in production on these distributed databases like Cassandra and HBase. But remember, these are like NoSQL databases. So the functionality they offer is like much simpler than what a relational database offers. Right? And so this is full of trade-offs. So, and we'll talk a little bit about why developers love SQL databases, but what are also some of the challenges with SQL databases, right? So I think most folks would agree that relational databases or SQL databases are very feature-rich. They provide a rich data model, a lot of query flexibility, the power of SQL to like add an index if your query pattern changes. You just create a new index and off you go, right? There's a very rich ecosystem. The skill set available of people out there who can leverage a relational database is massive. However, the main challenges with relational databases, at least in the past, where people are forced to go to a NoSQL databases, are primarily around some of these aspects. What do you do when your application is growing massively and it needs to scale? How do you deal with like failover, like a node is down, a disk is corrupt? How does the system have built-in resilience? And how do you build global applications that are highly available, highly localized, and can take data close to where your users are, right? So these are some of the challenges with traditional relational databases. So at this point, like, we saw how Facebook dealt with some of its scale problems. Let's switch over to maybe like how Google dealt with its scale problems, right? So do you folks know what database powers Google AdWords and Google Play? Which database powers Google's own advertising? So Google AdWords, Google Play, these are some of like Google services. What is it? Yeah, Spanner. Have you heard of Google Spanner? Yeah. Yeah, so in 2012, Google published a paper called Spanner. Spanner is, famously the first SQL database that scales horizontally on like shared nothing or commodity servers. And if you think about like the main motivation for Google building a SQL database that's perfectly like scalable to hundreds of nodes, right, is that in the past, their service was built on sharded MySQL, much like Facebook. But instead of going with a NoSQL solution, they went with, so their advertising backend actually went with fully relational database. And some of their key value propositions are horizontal scalability, globally consistent, relational database, right? So full asset transactions. I can take $10 from one row and move it into another row in an atomic transaction. Now, this is something that Oracle, MySQL, Postgres, they've solved it for 30, 40 years. But it is hard to solve it in a truly cloud-native, elastic manner. And the paper, that academic paper that they published in 2012 was a groundbreaking kind of paper. But the database that they implemented was proprietary. It's only available in Google Cloud as a service. So if you want something like Google Spanner, but to run in your own data center or in a different cloud, then you're out of luck, right? But anyway, that is the database. And essentially, I would say that is the fundamental inspiration for sort of the new class of distributed SQL databases, right? And it keeps the things about SQL databases that developers love, and it also removes some of the main challenges of relational databases. So it gives you this awesome combination of features. I won't walk through this entire list, but because we kind of touched upon some of these points, right? And I'll try to bring you over to what we are doing with Yugabyte to cover some of this. Also, a small digression. So we talked about what Facebook was doing. We talked about what Google was doing. Around this time, Amazon also started offering relational databases as a service. Except, and they had two. Like in 2014, they launched the Aurora with the MySQL dialect, and 2017 they launched Aurora with the Postgres dialect. Right. However, the main difference, what's going to maybe I'll pose it as a question. Compared to like Google's Spanner approach, do people know like how Aurora approach is different? Both are relational databases. Spanner is a relational databases and Aurora. But would love to hear from you if any of you have used Aurora or familiar with the differences. Exactly. So in Aurora, the primary database instance is still a single node instance. So unlike Google Spanner, which is a horizontally scalable architecture, where you can start with a small setup like 3 servers or 4 servers and keep adding capacity, in Aurora, the primary database instance is still a single instance. If you need more throughput from your Aurora database, you need to run it. Maybe you started with a 16-core server. Maybe you need to now go to a 32-core server. But at some point, you're going to hit the limit of what Aurora can do, right? But yes, its storage layer, like where it actually keeps the final bits of data, that is a multi-zone resilient layer. But the database is actually a bottleneck, right? They did add some read support. But if you need transactional guarantees, if you need strongly consistent reads, then you have to go to the primary, and all writes also have to go through the primary. So it's a single node database. It's really not a distributed database. Yes, its storage is distributed, but the database is not distributed. In 2019, they did add some multi-master support. But again, like Oracle RAC, it has restrictions. It can scale up to only a certain number of nodes. I think it can go up to like 4 nodes or 2 nodes. It's still a single region database, but there is also a lot of fine print, and there are a lot of caveats, and certain features only work in the more basic configuration. They don't work in the multi-master configuration. All right, so I'm going to switch over to introduce Yugabyte a little bit, because ultimately, at the end of the day, we are a transactional database. Would love to share a little bit of our journey, our decisions, what we are trying to do with the product, right? So we started in 2016. These are my 2 other co-founders, Mikhail and Karthik. We were folks that met and came together at Facebook around 2007, 2008 timeframe. And you could say we've been working together since then. But 6 of our years was at Facebook. And then in 2016, we founded Yugabyte. And in a nutshell, Yugabyte is a distributed SQL database built first and foremost for transactional applications. We are not an analytic first database. We are primarily an OLTP, or a transactional database, meant for powering your real-time applications, your user-facing applications, applications that simply cannot go down, right? And Yugabyte is 100% open source. It's an Apache 2.0 licensed database, and it's meant to run anywhere on your private infrastructure, public cloud, VM-based infrastructure, Kubernetes. You can run it in a multi-zone manner, multi-region manner, and so on. And in case you're wondering about the origins of the word Yuga Byte, it's really a play on words, Yuga and Byte. And Yuga is a Sanskrit word representing like a very long period of time or an era, right? And what we really mean it to mean data living for a long time, forever, without limits, right? Okay. In building Yuga Byte, we set out a few key design goals to begin with, right? The first generation of distributed databases was mostly NoSQL, mostly eventually consistent, like you said, no support for transactions and all that. But it became clear when we talked to a lot of organizations that for onboarding a large class of applications, having just the relational guarantees, strong consistency, ACID, and durability properties was super important. So consistency, scalability, being able to start small and grow as you need, and do that with built-in resilience. And resilience means two things, like how do you get your resilience? To get resilience, you need to keep multiple copies of data. Replication should be built in rather than a afterthought, right? But just having replication is not sufficient. You want the system to automatically fail over and have high availability if there's a failure. The failure could be a power outage of an entire zone, or just a disk corruption, or a single server failure. We built all layers in C++ for high performance. I'll come to the last bullet. One very important design principle was ability to do online reconfiguration or upgrade. So if you're patching your system for an OS fix that your security patch you need to pull up, or a database version upgrade, or just adding capacity, you're reconfiguring your system by adding capacity, or moving your system from public cloud to private cloud. And we've had all of this in our journey. We want all of that to be online operation, right? And so these were some of the design principles from day one, like no maintenance downtime for just doing a patching or a reconfiguration. The other thing was, how do developers interact with your system, right? And we didn't want to come up with a new dialect of SQL or a new language, right? And make it frictionless. So Yuga Byte is actually a multi-API database. It supports a relational interface. We call it YSQL, and I'll talk about what flavor of relational interface we support a bit later. We also support a NoSQL style interface, and that's based on Cassandra. Like a lot of our team had worked on Cassandra earlier at Facebook, so we support, and that we call YSQL. That's inspired from the Cassandra query language API. And this slide also covers a little bit of the architecture of Yuga Byte. So the lower half, our transaction layer, is distributed in a log structure storage engine, and it supports automatic sharding. So your tables can get big, and the system will just automatically, split the table into shards, and things move around. As an app, as a user or consumer of a database like this, you don't have to worry about that sharding, right, or load balancing and so on. Meanwhile, we were not the only company or product builders that were thinking that distributed databases have to be transactional, right? So even some of the NoSQL databases were moving in that direction. By the way, we talked about Spanner. Spanner was, in 2012, when the paper was published, it was only used internally for Google services. In 2017 is when, so we started Yuga Byte in 2016. 2017 is actually when Google offered Spanner as a service, as a DBaaS service that end users can consume. Some of the NoSQL vendors also, like DynamoDB, MongoDB, they all started adding support for transactions. But this only reinforces the point that the guarantees of a relational database with strong consistency and is immense, right? It really makes app development simpler if you don't have to reason about consistency guarantees from your database. If I write a record, or if I want to write 2 records, that should be an atomic, durable transaction. The same time frame when we started building the database in 2016, we wanted to give equal importance to building the control plane or the manageability layer of the database and making it truly cloud native. Like if you want to create a Yugabyte cluster in AWS cloud or Google cloud or on-prem, that should literally be extremely convenient, and like it should be a matter of 5 minutes, like not more than that. Like all you should be able to say is, hey, give me a 15 node cluster of Yugabyte in these three AWS regions, right? And the rest should be like magic. Everything from bringing up the servers to installing the software, and the day zero to day one to day two operations around securing your cluster with like encryption on disk and so on. So we not only focused on building the database engine, but from year one, the control plane also was a product that we were building into the um, you know um, into the thought process and offering. So we'll cover a few areas of key design decisions. By the way, anybody, how are we doing on time? Okay, sounds good. Any questions at this point?
I have one question.
Sure.
The question is very specifically around the Cassandra, the choice of Java. Cassandra. What actually sort of led you to that, using Java as the engine for Cassandra?
And maybe there are two answers. So we are, Cassandra interaction happened twice. So once at Facebook and then once at Yugabyte. At Facebook, it was more a time to market decision. We were the Facebook Messenger was running on MySQL, and we wanted to feature like a search index, and MySQL would be too much load for MySQL to handle. So we had to quickly bring a distributed database into the market. And Java is a highly productive language. It's very rapid, very productive, and mostly so at Facebook, Cassandra was built in Java primarily for time to market, and we open sourced it, and DataStax has formed a company around the Apache Cassandra project and so on. But in Yugabyte, as we saw, we are a multi-API database. We offer a Cassandra compatible interface and MySQL SQL compatible interface. But that version of Cassandra is actually in C++. So Yugabyte is all C++. And mainly this time, it's just a thought process that if you're building a server for high performance, especially new technologies are going to come, right? Like based memory is going to come. So C++ is really the language we wanted to implement a highly scalable and performance system, be as close to the bare metal in terms of extracting performance, avoid garbage collection pauses and so on in a garbage collected language like Java. Okay, so what flavor of SQL or RDBMS to implement was an important question. And at least our observation was that PostgreSQL is on a dramatic rise, continues to rise in popularity. And even compared to MongoDB, we are seeing that its popularity continues to rise, especially in the recent years like 2018 and so on. So, and some of the reasons behind it is it's a very mature and proven API, very rich feature set, very extensible, and a broad, vibrant ecosystem around it. Postgres, even from day one, and some of this is like Michael Stonebreaker and their team of designing Postgres is a very extensible database. You could easily add a new type into your system, like a polygon type or a vector type. So many extensions available in Postgres, like PG Vector and so on. So it's always from day one, it was designed to be a very extensible system. So that's one of the reasons where it's very popular. Even among open source, and it has a very liberal license. It's a BSD license. It's like almost similar to Apache license, very open, unrestricted license. And so that was one of the reasons we decided to go that our YSQL API is pretty much runtime compatible with Postgres. And obviously in building that, we had to make a decision like, now, what percentage of those features of PostgreSQL do we support? Postgres has a long list of features, right? And not just your basic SQL queries, but stored procedures, stable functions, many extensions, row-level security, foreign data wrappers, triggers, and so on. So it is, remember, it's 30, 40 years of work, and we are starting from scratch building a database. And it's a scary prospect to try to build so much functionality. And by the way, Spanner didn't do it. Spanner, built kind of a dialect of SQL, small amount of functionality, right? They didn't try to take this approach of really like bringing in a lot of SQL cap. But we decided that we really wanted to support the full PostgreSQL API, but not just stop there. Fundamentally, if all we were doing is building a Postgres SQL compatible database, that's not where the value proposition is. The value proposition is back to some of the key things we talked about: scalability, built-in resilience, high availability, right? And so on. Like, make connection management in Postgres really simple. Make data migration to a database really simple, right? So one way to think about it is really Yugabyte DB is really our YSQL API is fully PG compatible, but with all the goodness of a really distributed SQL database, like a cloud native Postgres database is one way to think about Yugabyte DB. So how do we go about building it? Do we just try to hire thousands of engineers to catch up with 40 years of functionality? I mean, that would be a long journey. We were a startup. We had to find an optimal path to get there. And so we said, like, okay, like we also wanted to be compatible with the Postgres ecosystem. So if you are familiar with Postgres, you're going to probably go into PSQL, that's your command line interface to Postgres, and you're going to do /d to describe a table, see what's in my system. We wanted all that to work as is in Yugabyte DB, right? So that experience should be very similar. But what happens behind the scenes when you go into PSQL and type /d? Behind the scenes, it generates a fairly complex query to go to the catalog inside the Postgres database and look up like what are all the tables in the system, what indexes does that table have, and that query already has a whole bunch of things like functions and all kinds of operators, tilde, not equals tilde, left join, and so on. So it became pretty clear that if we try to implement all of this functionality one feature at a time, where it's both going to be very long time to market, and probably we're going to have our own incompatibility, small bugs, small differences, even adding two floating point numbers, the rounding calculations, if we get it wrong, that's a huge surprise for users. So one key decision we made was reuse the upper half of the Postgres code base almost as is in the Yugabyte offering. So Yugabyte is open source as well. We ripped up the lower half of Postgres' code base. We don't use Postgres' transaction layer or B trees or its indexing structures. That's all purpose-built by us in a distributed and automatically sharded manner. But in the language layer, we are actually just reusing almost half of Postgres code base. And this was okay. This is just this is about 5 years back when the you can imagine that while it sounds easy to take half of Postgres code base and put it on our sharded and wrapped replicated storage engine, but that's probably where a lot of the hard surgical implementation was. But as hard as it was, but it was a one-time effort that we had to go through. But suddenly, because of reusing that upper half, we get so much of that Postgres functionality: JSON-B data type, timestamp, interval, table functions, triggers, stored procedures. All of that works in Yugabyte exactly like how it works in Postgres. But what you get is this, massively scalable architecture that is a kind of like a future-proof way of building your applications, right, without getting locked into a single instance database. Sorry. Yeah. I think this was as a quick one. I mean, believe it or not, in hindsight it looks simple. When we started the company in 2016, we hadn't quite decided whether to open source or not, right? Remember, MongoDB had not gone public at that point yet. Elastic had not gone public, so the verdict was not quite out there whether it was possible to build a commercially viable company around an open source project. So I would say we kind of just delayed the decision. But in 2018, we went open source, but we did a hybrid. Like we put some features still closed source, and 90% of the features was open. But 2019, we just made a dramatic decision to say that the database is 100% open source, right? And obviously, we got good feedback from the community. Many of the people that are on the journey with Yogabyte today, and I'm happy to share, like Rakuten, especially Rakuten Symphony, that some of the Rakuten mobile telco, they themselves have been on the Yogabyte journey for a few years now. And so thank you to the Rakuten team for that as well, in addition to hosting today's event. It's been phenomenal. Like a lot of organizations really care that the products that they are using are developed and built in a very transparent manner. So when we fix a bug in our product or when a new issue comes in, everything you'll find on GitHub. And I think that culture of transparency is itself an asset. We have a active community. If you're not on our community Slack channel, welcome you all to join our community Slack channel at yogabyte.com/Slack. That's an 8,000 plus member community continuing to grow. Folks like Yogi are pretty active in responding to our users there. Thank you, Yogi, for that. And the journey is still on, right? And building it. And if companies like Oracle are still adding capabilities to the database, we're still early, young. But I think we're proud that we've come at it very rapidly. And this is just a sample of things as we've built over the years. Recently, Postgres is a generalized inverted indexes. GIN index is something that we recently added. And on day one, our database didn't have backups, but at some point we had to. So we added backups, and people said, "Okay, your backups are okay for kind of NoSQL like workloads because they're single shard consistent. But how do if my database is transactional but my backup is not multi-shard consistent, that's not enough, right?" But you couldn't build everything. So I think when did we have transactional backups? Maybe I didn't mention that. But then people said, okay, you have a backup as of 8 p.m., but can I do a point-in-time restore as of 7:55 p.m. or something? So features like point-in-time recovery, it's been a phenomenal journey, like fun journey. We work closely with our users and customers, who on this journey in prioritizing our roadmap and work. But if you think about it, there are no one-off kind of features that only make sense for this user or that, right? I mean, if you look at any of these things, like table partitions, row-level geo-partitions, these are all features that benefit a large number of use cases, applications. It's been fun. I don't know if I have a few slides on some of the Yugabyte DB use cases, because ultimately you're building a database for use cases. And we said, okay, we are not really in the analytic category. We're mainly focusing on transactional applications. I mean, here is a sample of things. We see companies like General Motors use Yugabyte for powering their OnStar telemetry use cases. So that's more of an IoT-like work for very high write volume, right? To retailers, and probably some of them are not publicly referenceable, but some major retailers using Yugabyte to power use cases like shopping cart, inventory, pricing, catalog serving. So read-heavy use cases, transactional use cases. We have a growing list of banks and financial companies that have applications running in production, brokerage firms. So it's been fun. And I'll skip some of these slides. I'd rather open it up to questions. And there's a quiz time too, but before I hand over to Yogi, I can take a question or two, maybe then we'll go back to Yogi, and then I'm happy to take some more questions. But Is that Sentinel, you think? Or
Citus, yeah.
yeah, Citus data. Yeah.
Citus data, yeah.
Yeah, yeah. And Microsoft acquired Citus recently.
Oh, really?
Yes.
Yep. But so I mean, I believe that's still open source. You can still use that on,
Yes.
on Postgres. But there are quite a few constraints
Yes.
in order to use that. Do you have those constraints? Is that the reason why you wouldn't use Citus and instead come to you guys?
A great question. So what Citus at the core, one way to think about it is Citus took a bunch of Postgres instances and they added a distribution layer on top. And so, yes, your query comes in, it can route you to the particular shard and so on. That architecture has some advantages if data totally lives within a shard, but the application has to be a little bit shard aware. All your tables and indexes need to have a shard key. But the main catch is it's not truly a distributed database. I cannot say in Citus that my email address column has to be unique because like referential integrity constraints, all of them work only within the scope of a single shard. So sharding is a very explicit concept in Citus, but it's not truly a distributed database. Yugabyte inverted that a little bit. Yugabyte said we'll take the upper layer of Postgres, rip out Postgres' engine, and the engine is fundamentally a distributed transactional store. Because Yugabyte supports distributed transactions as a first order primitive, that is the reason even if I have a 5 billion row table in Yugabyte, which is distributed across this, I can say that the email address column needs to be unique, right? And this is something you're used to in Oracle, MySQL, and Postgres, but you can't do in Citus because it's not a truly distributed database.
Sorry. I'll come to you next.
I had two questions. So on one of the slides, you mentioned that Yugabyte adds a lot of things on top of Postgres, one of which was connection management. In my experience, that's been a pretty sad story on the normal vanilla Postgres side. So maybe can you talk a bit about what's changing over there?
Yeah.
And the second thing is you mentioned that you're also using only the upper layer of PG. So like, does it mean you're just getting the primitives from PG over there, or what's the story with the query planner, for example? Are you implementing your own?
Good question. So remind me, what was the first question again?
Connection manager.
Connection manager. So, I mean, so it is in tech preview, this particular feature built-in connection manager. But as you know, in traditional, in a single node database, connections are sticky. And if you have an application tier where you're suddenly, like, say, because of load, you're suddenly scaling up your app tier. It's like Kubernetes based, and you're just launching a lot of application instances. That's going to want to create a lot of connections to your database. But at some point, Postgres, once you have more than like 600 connections or so against the instance, it'll start to reject connections, right? So how do people work around it? They usually put a connection pooler like PG Bouncer or Odyssey in front, and that's essentially multiplexing thousands of logical connections onto a small number of physical connections. But our goal is like the database needs to just solve this as a building block, and so with the newer versions of the upcoming versions of Yugabyte, the connection pooling capability is just natively built into Yugabyte. For the end user, you're just getting the benefit of connection pooling, and you'll be able to configure some min-max and things like that around it. But it's just built in as part of Yugabyte. So that is one. This speaks a little bit to the query planner, right? So by default, we are not just getting the types and the, like suppose Postgres, I can concatenate 2 strings, or I can add, dates, and it'll do the date arithmetic. Of course, we're inheriting all of that. But even the query planner as a starting, but that's not sufficient. The advantage of inheriting the query planner, like if even you're doing a join, whether it's picking a merge join or a nested loop join, hash join, we get a lot of those building blocks and the structure and how somebody, a database architect that's tuning your application, you might do an explain, analyze to look at what your query is actually doing, right? Is it generating a hash join? Is it using the right index? By leveraging all of that in Postgres, that experience is the same, and explain, analyze just works. You can go into Yugabyte CLI or PSQL. We have called it YSQL shell, but it's really like a fork of PSQL, and all of that works. However, while the default query plan might be okay for very simple OLTP queries, as your queries become more complex, and you have a lot of indexes, and query optimizer has to choose the right index and the right query plan, we have to do things. We have to enhance that query optimizer to be more distribution aware. The fact that Yugabyte is a different architecture, the cost of going to a table which may be in a different node is higher, and so on. So we have done moving more toward the cost-based optimizer. That's in coming up in tech preview. Right now, it's more a rule-based optimizer, and Postgres itself has those two models. So that's where we start. So while we benefit a lot from it as a starting step, but that's not sufficient. We need to take it further especially as you get into more analytic type queries.
Mine is from an end user perspective. So if database is usually very dry, one of the driest, that's why the cool stuff is always non-database stuff. So I was thinking, does Yugabyte make it more sexy? That's one thing. The other thing is why sometimes, in my exposure to all my developers, right, nobody want to touch the database. That's why for database transformations from Oracle, usually it's very slow because it's something that's very hard to touch. And if you plant databases at the edge, that means at the front end, usually the mandate requirements, you must have an uninterrupted power supply, because if power goes down, the database need to. But does Yugabyte, because you mentioned about on-prem and cloud native, because Kubernetes for us, we try to make it the infrastructure very unstable. Does Yugabyte solve this unstable issue that traditional database required?
Yeah. Yes, something like database. If you think about a lot of the features we are talking about are not fundamentally new. Like, people have heard of this in the context of other databases like Oracle and so on, right? Like, online index rebuild. Of course, like in Oracle, if I create an index, it's an online operation, and so is it in Yugabyte. So some of these are not new, but solving it in this kind of a distributed architecture where the users of the product get an aha is in a few different cases. Firstly, it's enabling them to build almost new kinds of services. There are many use cases today that simply an Oracle rack is very hard to handle. It's a kind of scale. Like, if you just look at the Indian market and the number of UPI, these online micro payments and transactions that are going on, the volume is at a level that there is a need for a fundamentally new, highly scalable architecture. So that is one part of the right. And the other part is like really doing these systems in a way where if there is a disk failure or a power outage, it is not a P0 issue. It's there. I can replace the node tomorrow, right? Really making infrastructure not be a stress, but something that the system has healed itself. It's okay to add the node back tomorrow, right? That's like building resilient self-service, self-healing systems. In a way, it's designed to be like invisible infrastructure, and it's hopefully something that people don't have to worry too much about. And that's part of the problem you're trying to solve. Right?
Just to add to that, we have actually seen some of our open source users use Yugabyte on the edge, on the likes of like Raspberry Pi, extremely low powered devices, and like remote areas where they are able to, because of the distributed nature of Yugabyte, they're just able to, like, just as Kannan mentioned, if a Pi fails, that's fine, I'll replace it in a day. That's fine. I'm not going to sustain any service loss or a data loss.
Like one of the, maybe this slide is one of the big top 5 global retailers, a US-based retailer, they effortlessly survived a major Texas power outage. Texas usually doesn't get snowstorms, but about a year and a half back, there was one of the Azure data centers was without power for more than a day. And Yugabyte was one of the few services that didn't need manual intervention. The system was still up, serving from the other two copies of the data. So a very typical deployment of Yugabyte is with the replication factor 3. So any row is at least in 3 places. And those 3 places could be multiple zones inside a geographic region. Or in some cases, people actually pick 3 different geographies, right? And when the Texas data center was without power for more than a day, Yugabyte was still happily running, serving data from the other 2 regions. And this incident has really happened, 18 months back.
Thanks for the talk so far. Quick question. From what I remember from the spanner, a lot of that hinges on the bone network. How does Kanban? I don't know if that.
Yeah, I got it. I think you said, the spanner paper, especially for the distributed transaction protocol, relies on atomic clocks, right? And so now, we essentially have a similar thing, and it's like two key things. So we are based on hybrid logical clocks, and there's a paper published on that topic too. So that I would encourage looking that up. And we have documented our transaction protocol. But one of the things is many cloud providers, are equally providing a very high precision, reliable ghost queue clock, and that just looks like NTP to us. So Yugabyte, software-wise, we use NTP clocks, but the cloud providers provide through the NTP API much more higher precision, lower clock skew services, and we have protection built into the system that if the clock skew is more than a certain thing, we prefer consistency. So in the CAP theorem, sometimes people ask, where is Yugabyte? We are a CP database. We prefer consistency rather than giving an incorrect answer.
One last question.
And we'll go over to the quiz at Yogi's.
Just a general product-based business question. You built your product mainly on top of Postgres.
Yeah.
What sort of risks do you anticipate? Because Postgres publishes at a healthy cadence, I guess. 17 will come out maybe next year. What if they make architectural decisions, which will make it tough for you to guarantee that compatibility going forward?
It's a fair question. But in general, even for Postgres' community, leave Yugabyte aside, a new release, and most, if you look at Oracle's feature release or Postgres' feature release, they will maintain backward compatibility. So they'll keep adding features, but not break the functionality of existing features, right? And so most good software engineering, that's the path they'll take. So we do fully expect to keep rebasing. In fact, right now we are undertaking an effort to get to Postgres version 15. So that effort is underway, and we'll keep staying close.
So it's time for quiz now. Thank you very much, Kannan. Can we have a round of applause for Kannan? Thanks, everyone. All right. So I have 2 microphones. I guess I can use just one. So based on what you heard today, have I given out the answer? No. Okay. Who wants to go at this? Okay. I saw your hand first. What's the answer, sir?
All of them.
All of the above? Ding, 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 ding. All right. Meet me later for your swag. All right. Next question. Show of hands. Fastest finger first. Okay, I saw you. Sorry, A and B. So you're saying YSQL and YCQL? It's E. I'll give it to you. I'll give it to you. All right. Fastest finger first. Ding, 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 ding. You've already asked a lot of questions. You're not getting a chance. All right. Your answer is seesaw. Does everybody agree? Who doesn't agree?
Is everyone getting back?
Don't give away that wish. All right. Ta-da! All right. Next one. Come on. New hands. Okay. Bajitan gon mil. Good. What's your answer, sir? Should I lock that? D raft? Everyone agrees? Who doesn't agree? Come on, somebody has to disagree. It's a free country. Come on. All right, D. And last one. Where can you be deployed? Okay, I saw your hand first.
Okay.
All of the above? That's what? E? Sure? Ta-da! All right, those were my 5 questions. And now, on to the next one. I know this was a great session. I learned a lot, even been working at Yugabyte for a while. It was a great session. Thank you very much, Kannan, for that. Now, over to my friend, Wanxiang from IMDA. I've been working with Wanxiang for about a year and a half or so.
Yeah.
I suppose that. Yeah. And he's here to actually talk to all the budding entrepreneurs and startups in Singapore who are trying to actually find out new schemes from the government to actually enhance your experience. So without any further ado, over to you.
Oh, thank you. Where's the slide clicker?
You can use this clicker, sir.
Okay. Before I turn, let me do a quick intro. My name is Wen Xiang. I come from IMDA. So probably some of you were interested how government played the role to help Yugabyte or help to other companies. Okay, I'm come from the division called Enterprise and Ecosystem Development. Our primary job is to help disruptive and promising Singapore local startup companies to grow, to make the ecosystem more robust and more variant for our ICT systems. So what I want to throw out the first question is the innovation, right? Before I joined this company, I feel I understand the innovation much better. But after working for a few years, I feel that I don't have the definition of what is innovation. So I'm not sure how many of you has the experience to deal with startup business or startup companies. Maybe raise your hand to let me have a few. Okay, not many of you. So probably that I will share you the few challenges that for the startup company, the companies that we are dealing. The really challenges is that for startup company, they have a very good idea, very great innovation in terms of building their solutions, building their products. But when the situation comes that turns the solution to addressable SIMs to the market, to the production, for example, it's very challenging for them to deliver the SIMs. The product is good, feature is good. They really can help the business user to achieve their needs, but convert an idea to production. That is a very challenging thing. So along the years of working, we feel that we really can do something as a government body. We have quite a lot of team members, very experienced from the industry as well. So we come up with an idea called Tech Acceleration Lab. Where's the button to click? Okay. So we understand that for innovation solution to be adopted by buyers, right? So usually the innovation, the first one who eat the crab will be very risky to spend the time, spend the cost, but eventually something may fail. So what we do is that we help the company to do their POCs within our environment. So as I mentioned just now, startup company, mostly the more younger company. Of course, Yugabyte is more mature in our portfolio, but some of the companies, they are really young. Their CTO could be more younger than me as well. So they have no experiences in terms of how to address enterprise customer needs. They even don't know how the tiering concept. Actually, yesterday I talked to a company. I conducted a workshop to them to give them a brief knowledge about that. They told me that my solution is all in one box. So my web tier, my application, my database, all in one. The solution works, but in order to deliver the solution to enterprise buyers, actually they have quite a long way to go. Not for the feature, it's more for the enterprise grade requirements. So in order for a POC to happen, we identified two major challenges. One is the POC environment. Okay, POC environment usually is not pertaining to startup companies. It's more for the buyers. For example, I am a agency project manager. Of course, you are coming from various industries. You could be the one want to try some solution. So firstly, you are saying that where am I going to deploy the solution to? Probably you need to request some funds, get approval, get some spare server to get the solution to be able to address your needs. So that is the typical challenge in government. We also feel that I want to try something, right? I need to procure my government compliance servers to validate the infrastructure requirement that the solution really can be. That could easily take up to 3 to 6 months in order to get environment ready. Okay, that is not a problem to start up, but directly affect startup to survive. For example, startup companies sometimes they are short of cash flows. They could turn down maybe without any deals coming in. So that is a very crucial element for our companies. So that is a POC challenges. Another is the deployment requirement. As I mentioned just now, startup company they could build their solution all in one box. So a lot of enterprise grade, for example, in banking, in government, in other industry, they will have the minimally architecture requirements. They probably will face a lot of challenges to understand the enterprise grade needs. So that will bring them a lot of challenges for delivering their innovative solutions. So this is what we are trying to address. Okay, it's okay. So what we come up with the program called Tech Acceleration Lab. Tech Acceleration Lab, initially we want to help the startup company to better grab government deals. We give them a lot of privilege in terms of securing government deals, but come to deployment, we got a lot of feedback that they are really short of experiences. They need the customer reference. They need the first project to start with to practice their skills. Initially, we only do advisory, do coaching, but no hands-on. Actually, the pickup rate will be very slow. So what we do is that as long as the company is under our portfolio, we will give them the exclusive privilege to try the Tech Acceleration Lab. Okay, maybe I introduce a little bit the accreditation and spark companies means that in our program, we do a very robust evaluation to make sure the startup products can really deliver what they claim. For example, if the company, a lot of business, they just sparkling their ideas, sparkling their roadmap, but in the real use case, deliver. So in my team, for example, me, we have a group of people who are all come with technical background. So we will validate the typical function of the products. Of course, we also do validation, due diligence to make sure the product performance efficiency, the security meet the government agency requirements so that they can proceed to be listed on the privileged Greenland in our program. So when we come out the sorry. Maybe my voice triggered some silly stuff, is it? Okay, let me proceed. No problem. What we always do is instead of let the company proceed to try the things, we realize that we need to give them a quite robust advisory, especially the government requirements, to coach them up from before they propose their architecture. For example, we tell them what is a tiering requirement, what the basic architecture they must fulfill in order to let our side to further help them. The advisory we also come with quite experienced staff. You know that for us we could limited in some areas of work, so we also outsource to some of the work to the industry experienced people to help us to deliver the work as well. Actually, sorry. Okay. Okay. In terms of the real sandbox, we come with two portions. The first one was introduced in 2021. 2021 is only for government users. Government user can try their interested solution in our sandbox immediately without the 6 to 9 months waiting time. The sandbox right now it is called Government and Commercial Cloud. If you work in public sector, you will know it's called GCC. The GCC consists of AWS, Azure, GCP, and we also have the GCC Plus upcoming in the next 2 months. GCC Plus will be quite different. If you work in the public sector, you will know that something challenging will coming soon. In this year, August, our Minister Josephine Tu shared that this sandbox is available for enterprise customers. With only a few months pilot, right, we already generated about enterprise POCs, which means the customer really trying it, and some of it they already convert to the real contract. Of course, that one Yugabyte contribute some number to it. So this is just an example architecture what we have done for our companies. So this is not a real use cases because we didn't collect any consent from our companies. So for example, the case I mentioned just now, some startup company they just come up with one box solution over here, but the solution is not tiering according to different regulation or compliance requirements. So we will at least make them be able to fulfill this example. This example means that at least they got the different network segregation, security control, and different layer of things to handle minimum requirement. Of course, this one, if you are experienced in architecture, you will know this one actually no HA built in. Of course, there's no best architecture, but it's more important to pertaining to user needs. In government, of course, as long as the system cannot be done for a certain time, they must build the HA architecture to be available. Of course, if you are using Yugabyte, for sure the HA is a must to do, right? Okay, this is some endorsement from our companies. I replaced the first one to be Yugabyte. The comments is coming from the CTO from Yugabyte, and actually I work with Yuki very often. Even during offline, we do regularly catch up. I still remember that during evaluation, Yuki gave me the refreshment course on databases, although I returned the knowledge to my teachers very long time ago. Not just Yugabyte in our portfolio, we also have other companies like Data Robot. If you heard about it, it's helped you to deliver a machine learning in a very fast and quick manner. This is a very powerful tool, so very recognized by the industry. Some other solutions like Impress.ai is the HR software. It is come with a lot of machine learning and efficiency capability behind. And we also have the customer. This is our first pilot agency to help us to validate our concept. And if any of you heard about Upper and Confluent, they are all quite recognized. Initially in our program, they are very younger startup companies, but now they are already well accepted by the industry, also accelerated through TAL. I will share more cases, but I believe you are more interested in terms of what you can leverage this sandbox to achieve. I posted a few QR codes just in case someone who want to scan it to see through. Or simply you just Google IMDA accreditation. You go to our public website to know the list of companies, the company use cases. In the middle, that is a category of our available company. I believe right now it's more than 70, around 80, that number of companies. So you got various solutions to choose from. And just be reminded in our tech assessment lab, right now, due to some reason, we can only allow this list of companies to be tried in our solution. But another angle to leverage these tools is that, for example, one of the solutions I work with Yuki is that Yuki come with a database, right? Database alone, it cannot work, right? It doesn't address any ICT digital needs. So what we do is that we find another partner, another solution on application layer, or another solution that on data analysis layer. We can build the use cases with a combined solution. So as long as the solution come any of the accredited Spark company use, Tech Assessment Lab is more than happy to help you to validate the proof of concept. Okay, I will go through some of the FAQs. Firstly, is that how does IMDA decide which tech startup company can be part of TAL? This one I have shared that only accredited and Spark company can be part of it. Why is that? Our mission is to drive innovation adoptions. So as long as the company come with the solution which is innovative enough and bring a lot of positive impact to the ecosystem, our team spend a lot of effort to shortlist those companies, evaluate the companies, make sure the company can deliver what the enterprise grade customer needs. We will put them in the Spark program. So that, as I mentioned just now, you should have sufficient list of choice to select from, to try to make your organization, your current project portfolio be able to adopt innovations. Okay, second question is that what are the costs could be in liberating TAL? TAL right now is a government program that is come free with you, and you got a full bunch of team members, my team members, to handhold the company to deliver the POC project in a very fast manner. Our key value is to accelerate the POC. We don't want to drag the POC forever long. We want to address your needs as soon as possible. The third question is, can I use my own production data in TAL for the POCs? Okay, I believe majority of you are coming from data domains. You know how data is important to organization. So we don't want you to bring the production data for POC use cases. So although that in our underlying infrastructure, we have quite robust monitoring and log control to kind of stuff, but we still don't recommend you to bring any production data. You can do some sanitization on your data, bring a set of test data with very clear POC objective. So our environment will more than happy to handhold the POC to happen. The integration has been allowed to the test environment. Yes, our environment is very flexible. We allow your environment, for example, you got a staging environment, you want to validate your solution, you can direct to the connection, either VPC peering or either through some private link or through net, whatever. You can do the talking to each other. You can validate the solution very fast manner. Do I have more questions? Oh, that's all for my questions. Maybe I can also throw out to ask if anyone have any questions about the Tech Assessment Lab, or maybe you got some idea. You can directly contact us. I remember we got the email. Okay, the email is not listed here, so probably that previous slide. Oh, sorry, I'm quite nervous on that. So our email is that tech_acceleration_lab@imda.gov.sg. So you can inquiry with any of the question you have if you don't come in your mind right now, and you can always bring your POC context, we can try to quickly facilitate that on that. So maybe on the spot, any of you got any questions?
What's the limit of the cloud cost you cover?
Sorry, you mean the maximum cost, right? Right now, we haven't seen any POCs exceed our budget. POC is not the full production scale. Even if you use, I remember last month we delivered a kit with more than 50 servers. That is still within our budget. So for POC purpose, no worry on that. Of course, case by case, once you come with the context, we will review and try our best to facilitate.
Short answer. How much data you got? Any last questions? All right.
Okay.
Thank you very much,
Thank you,
Wenxiang.
thank you.
Always a pleasure. All right. So we are slightly over time, but I think we are perfectly well within. Hang on. Yeah, it's fine. All right. So we would like to get some feedback from all of you. And as a thank you, we would like to, let me move this out. As a thank you, after you've given us the feedback, please keep the page open or take the screenshot and do collect your swag on your way out. All right. While you are busy in submitting your important feedback, it's very important for us. So please, everybody, I request you, I urge you, everyone to give us your feedback. If I don't see phone clicking pictures, you better be filling the form. You're an exception, Tekchun, because you're going to come and close the event for us. All right. Is everyone able to scan the QR code? Anybody not able to? I've written the URL as well. And please don't take that screenshot and show, okay? Laila, don't accept the the form with 55C7 at the end. Okay, can I take down the slide? Okay, so before I hand it off to Tekchun, I'd like to thank all of you for coming today, and especially Kannan for actually spending so much time with us and walking us down the memory lane and the database world. I learned a lot today. I hope all of you did. And of course, Wenxiang for an excellent overview of the TAL lab. I hope a lot of you go back and think about various contexts and POCs that you can think of with the TAL lab. With that, Tekchun, over to you.
Thank you, Yogi. And thank you again to Yogabyte and Kannan for the presentation. It was very interesting and enriching. And thank you very much. Learned a lot today as well. And thank you again, Rakuten, for the venue. And I'm DA for the event and learned a lot about TAL as well. So maybe we should all go back and think about new startup ideas. So it's great. The government is supporting us, right? Okay. 15 minutes. Okay. Can't talk so long. Yeah. Okay. Anyway, yeah, thanks for coming. You want a group photo? Is it? Group photo? Sure. How you want to do it?
Photo!
Yeah, okay. So photo time. All right. So I think after that,